This is stoichiometry test review questions 7 and 8. For 7, we are given the chemical equation already balanced, and we are given two masses, one of aluminum and the other one of copper 2 sulfate. So those are our two reactants here. So whenever we're given two masses, we should treat that as separate stoichiometries. We're asked how many grams of copper are formed. And so we'll start our first stoich. 25.3 grams of aluminum over 1. We're going to go from grams of aluminum to moles of aluminum. The only thing that you can convert grams to is moles. We wrote moles, so we need to immediately write moles again of aluminum. And then we go back to our question. It asks us about copper, so we're going to do our mole to mole ratio for copper. Then I go to I wrote moles of copper down here, and then I need to go to grams because it's asking about grams, so grams of copper. Now I'm going to go back to my periodic table and look up the mass of aluminum, which is 26.982. And the periodic table is always in 1 mole. I look at my chemical equation for my mole to mole ratio. The number in front of aluminum is 2, so I put a 2 here, and the number in front of copper is 3, so I put a 3 here. Back to my periodic table, the mass of copper is 63.546, and the periodic table is always in 1 mole. Multiply 25.3 times 1 times 3 times 63.546. Divide that by 26.982 times 2, and you get 15.1093. The next one is also 25.3, but this time we're going to do copper 2 sulfate. So 25.3 grams of CuSO4. I need grams of CuSO4 down here. The only thing we can convert grams to is moles. Then I immediately write moles of copper 2 sulfate down here. And this is where I'm going to do my mole to mole conversion, so I need to go to the product that I want to compare. And then moles of copper to grams. I already did this up here, so I'm going to just use that again. 63.546 grams of copper. I'm going to go back to my periodic table, add up the mass of 1 copper, 1 sulfur, and 4 oxygens. That gives me 159.608. Periodic table is always in 1 mole. The number in front of copper sulfate is 3. The number in front of copper is also 3. Periodic table is always in 1 mole. Multiply the tops, multiply the bottoms, divide the top by the bottom, and I get 10.0729. Okay, so this smaller amount tells me that copper 2 sulfate is going to run out before aluminum, so my limiting reactant is copper 2 sulfate. My excess reactant, the one that has leftover, is aluminum. And I can only make 10.0729. I look back, I have 3 sig figs, so I only can have 3 sig figs in my answer. I look one past, that 7 tells me to round that 0 up, giving me 10.1 grams of copper. For number 8, we're given the chemical equation already balanced, and it asks about 5 0.45 grams of potassium chlorate, and it decomposes into oxygen and potassium chloride. Then it asks us to find the theoretical and percent yield. Since it gave us this mass right here, 1.75 grams of oxygen, in order to do a percent yield, we need the same molecule that they gave us that was produced. So we need to do our Stoich of potassium chlorate to oxygen. So I'm going to put my 5.45 grams of KClO3 over 1. I'm going to need grams of KClO3 here, because remember, whatever unit's here goes here. The only thing grams can convert to is moles. I think I'm going to run out of room on the board. Okay, so moles of KClO3, and then I want to go again to oxygen, so moles of O2, and then I'm going to put moles of O2 here, and that's going to go to grams of O2. I'm going to go back in and fill in my numbers. Grams always comes off the periodic table, so I'm going to add up potassium, chlorine, and 3 oxygens. That gives me 122.548 grams of potassium chlorate. Periodic table is always in 1 mole. I look to my chemical equation. The number in front of KClO3 is 2. The number in front of O2 is 3. Go back to the periodic table. Periodic table is always in 1 mole, and then we add up the masses of 2 oxygen, which is 31.998. Now, when you multiply the tops and multiply the bottoms, you get 2.1345 grams. We are told that 1.75 grams was actually produced, so that's our actual. Our theoretical is this number right here. Multiply all that times 100, and you get 81.9849. I never round until the very end. So rounding, I have 3 sig figs, 3 sig figs, 3 sig figs. Now, this 8 tells me that I need to round up that 9. When I round up that 9, it becomes 10, so this becomes a 0, and that 1 becomes a 2. Giving me 82.0, we have to include this 0, it is significant, percent.